Good morning, class. Last week we were able to look at the electronic configurations of different elements, and these elements actually are located in the periodic table. In today's lesson, we are going to look at the history of that periodic table, how it came into existence until we have the current day periodic table. So, even before the scientific discovery of elements that occurred in 1649, elements like gold, silver, tin, lead, and mercury had been known by people. That means that the discovery of elements began a long time ago. That is before the scientific discovery of elements that occurred formally in 1649. By the middle of 19th century, about 60 elements had been discovered by scientists, and now these scientists began to realize patterns, and they came up with the idea of classifying these elements in schemes. These scientists are discussed in the following slides. We have about 4 scientists who contributed to development of the current periodic table. To begin with, we have this man called Alexander Beguya, who in 1862 listed elements on a paper tape and wound them in a spiral like around a cylinder. When he did that, he noted that certain elements with similar properties came down the cylinder together. Then he called this model a telluric screw. I'm going to show you the telluric screw in the next slide. Let me show you. So this is a telluric screw. On this side, on the far right side, we have a cylinder containing a sheet of paper that has been wrapped around that particular cylinder, and when the paper is unwrapped, we look at it on the left side. As you can see, the elements that lie below each other have similar properties, like calcium and magnesium and beryllium. All of them lie below each other, and they actually have, even up to date, they have similar physical properties. So that is what we call a telluric screw. Now the next scientist was John Newland, who in 1864 noticed that if elements were arranged in order of atomic weights, there could have been periodic similarities after every 8 elements, and therefore he proposed the law of octave, which actually states that elements with similar properties would repeat approximately after every 8 elements, creating a regular pattern. Now next scientist is this man called Lothar Meyer, who in 1869 compiled a periodic table of 56 elements based on regular repeating patterns of physical properties such as molar volumes. And once again, this man arranged the elements in the order of increasing atomic weights, just like the previous scientist. Then we move to the next scientist whose name was Dmitry Mendeleev. In the same year, Dmitry Mendeleev, in the same year, that is 1869, produce a periodic table based on atomic weights, but in this time round he arranged them periodically. And then you notice that the elements with similar properties appeared under each other. This was a very great idea toward the development of the current day periodic table. While he was arranging these elements periodically, he left the gaps for elements that were yet to be discovered by then. Then in 1894, William Ramsay, who was also a scientist, discovered the noble gases, and actually the noble gases represented a new group in the periodic table, and even up to date the noble gases lies at group 8, that is the last column in the periodic table. Later on, that is in 1914, Henry Moseley determined the atomic number of each element that had been known by then, and he realized that if elements are arranged in order of increasing atomic numbers other than increasing atomic weights that were done by other scientists, they will give a better fit in the current day's periodic table. And therefore, he proposed the arrangement of elements based on increasing atomic numbers so as to overcome the challenges that were faced by earlier arrangement of elements based on increasing atomic weights. Now let us look at the modern day periodic table. Since Mendeleev did a lot of contribution to the periodic table by arranging the elements in order of increasing atomic numbers, and even up to the day-to-day periodic table, elements are still arranged in order of increasing atomic numbers. You find element of atomic number 1. Atomic number 1 is number 1 in the periodic table. The element atomic number 20 is number 20 in the periodic table, all the way to element number 118 that has an atomic number of 118. Now, the modern day periodic table is an organized arrangement of chemical elements based on atomic numbers, as I have said, which reflects the number of protons in an atom's nucleus. The protons are located in the nucleus, like we saw in atomic structure. Electrons are located in the energy levels, and neutrons are also located in the nucleus. So what gives this atomic number is the number of protons in the nucleus of each and every element that we have in chemistry. Now, the periodic table is structured into periods, as I am going to show you in the next slide, into periods, that is horizontal rows. Periods are placed horizontally, and groups or families that are placed vertically or in columns. So the columns in the periodic table represent groups, or what we call the families, and these families possess similar properties, that is, when you compare the chemical properties and chemical properties, you realize that the elements that are in a particular group, like group 1 elements, they will possess similar physical and chemical properties. So let me show you a periodic table, that is the present day periodic table that we have. As you can see, we have period 1 all the way to period 7, and group 1, group 2, and in between group 1 and group 2 we have transitional metals, and then we have group 3, group 4, group 5, group 6, group 7, and group 8, which is normally indicated as 0 because they are noble gases. Otherwise it is group 8. Down there we have the lantanides and actinides. These are the heavy elements, that is from atomic number 57 to 70, and also from atomic number from 227 to, not 227, but 89 to 102. When you look at these actinides and lantanides, they are the element that we saw in the electronic configuration. Their last electron enters the F orbitals, and when you count in a row, there are 14 elements and there are 28 in number totally. So this is the periodic table that we have. We will continue to study trends in the periodic tables, that is during our next lesson. So for now, you have a good day, and see you in our next lesson. We shall come and discuss the periodic trends of elements in this kind of periodic table. So thank you. You have a good day. See you in our next lesson.